So yeah, let's start it now. So in VTP we are also having another concept of VTP, which is known as VTP pruning. Fine. And remember that this VTP pruning will always be used to prevent your switched network from unnecessary flooding. Right? So I was telling about VTP pruning. So as I said that, okay, this feature of VTP will prevent your switch network from unnecessary flooding. Let me tell you that how how switches performs unnecessary flooding, right? Let me tell you. See what happens actually. For an example, let's say that this is switch 1, this is switch 2, switch 3, switch 4, this is switch 5, this is switch 6. There is a user behind switch 6, and of course there is a user behind switch 5. So here we are having users behind switch 5 as well as switch 6. Fine. Let's say this is 0 by 1, this is also 0 by 1, this is 0 by 2, 0 by 2, 0 by 1, 0 by 1. Fine. 0 by 3, okay. Now let's say that the user behind this switch 5 is in VLAN 10. This user is also in VLAN 10. Now let's assume that the IP address of this host is 10.1.1.1 and the IP address of this host is
0 by 2, which one? 0 by 4.
Let's say this is 0 by 4. Fine. So behind switch 5 this user is in VLAN 10, behind this switch 6 this user is in VLAN 10, and the IP addresses also belongs to same subnet. It means they must be able to communicate with each other, right? Alright, let's assume that VTP is pre-configured in this topology, means VTP is already running on all devices. It means that VLAN 10 will be existing on all devices, is not it? VLAN 10 is existing on all devices like switch 1, switch 2, switch 3, switch 4, switch 5, switch 6, but actually VLAN members are present behind switch 5 and switch 6 only. VLAN members are not available like on switch 1, switch 3, switch 4 as well as switch 2. Fine. So if VLAN members are not available here behind switch 1, switch 2, switch 3 as well as switch 4, but the thing is, like as I said, that behind switch 5 we are having this user in VLAN 10, behind switch 6 also we are having this user in VLAN 10, and one more thing, that VLAN 10 is existing on all switches, right, due to VTP. Now because this VLAN 10 is existing on all switches, what does it mean? That whenever this PC will require to communicate with this 10.1.2, which is configured on this PC connected to switch 6, right? So this time it will generate one ARP request from here to get the MAC address of 10.1.2. Fine. So it will broadcast its ARP request from here. Fine. Then this switch 5 will also set a copy of that frame out from this 0 by 3. Then this switch 3 will receive this ARP request on its 0 by 3. Then this switch 3 will also transmit a copy of that broadcasted frame out from this interface, as well as out from this interface. And let's say that this is in blocking state due to STP, because STP is already configured here, right? So STP will be running on all devices, so that here there will not be any switching loop, there will not be any bridging loop, right? So due to STP, let's say that this 0 by 1 on switch 4 is in blocking state. So switch 3 is gonna to transmit one copy of that broadcasted frame out from its 0 by 2, out from 0 by 1, as well as out from 0 by 4. It's not it, this is 0 by 4. So finally this switch 6 will receive it here, switch 6 will transmit it towards this host, and finally this host will provide ARP reply. Are you getting my point? So now you can see that switch 3 has also transmitted a copy of that broadcasted frame out from 0 by 2 as well as 0 by 1. It means switch 1 is going to receive this ARP request here, and ARP request is always broadcasted. Then after switch 1 will transmit one copy of that broadcasted ARP request towards switch 2. Is there any user in VLAN 10 behind switch 1 and switch 2?
No.
Was it really necessary for switch 3 to transmit one copy of that broadcasted frame towards, in the direction of switch 1 and switch 4? Tell me, was it really required? So that's why I'm saying that in this situation now you can see that behind switch 1, switch 2 and switch 4, switch 1, switch 2 and switch 4, we are not having any single user in VLAN 10, but still switch 3 is transmitting a copy of that frame which is for VLAN 10 in the direction of switch 1 as well as switch 4 due to flooding only, right? So because switch 3 is performing flooding, and during flooding it is also transmitting a copy of that frame which is for VLAN 10 only in the direction of switch 1 as well as switch 4. However, we know very well that we are not having any single user in VLAN 10 behind switch 1, switch 2 as well as switch 4. So was that really necessary for switch 3 to transmit a copy of that frame in the direction of switch 1 and switch 4? Of course no, there is no requirement, there is no need to transmit a copy of that broadcasted frame in the direction of switch 1 as well as switch 4, because they do not have any user in VLAN 10. So I hope that now you have understood my concern here, right? So because switch 3 is transmitting a copy of that frame in the direction of switch 1 as well as switch 4, it means that now due to this flooding we are consuming network bandwidth unnecessarily. Is not it? It was switch 3 performed this flooding unnecessarily in the direction of switch 1 and switch 4, because we do not have any single user behind switch 1, switch 2 and switch 4 in VLAN 10. So have you understood it? So this is the problem which can occur in your live networks as well. Okay, to solve this problem now we have two solutions. Very first solution is, as you must remember, that we can modify VLAN allowed list. Is not it? By default traffic from all VLANs are allowed, is not it, through each trunk port. So here, because between switch 1 and switch 3 it will be a trunk port, right? Between switch 3 and switch 4 it will also be a trunk port. So by default traffic from all VLAN will be allowed through this trunk port. Fine. So what can you do now? Because you know very well that we are not having any single user in VLAN 10 behind switch 1, switch 2 as well as switch 4. So on switch 3, on this interface 0 by 1 and 0 by 2, we can remove this VLAN 10 from trunk allowed list, so that now switch 3 will not transmit a copy of that frame out from 0 by 1 as well as 0 by 2. Have you understood it now? Tell me. And this is not only for broadcast frames, because sometimes your switch will also perform flooding for unicast frames, sometimes it can also perform flooding for multicast frames as well, as I discussed earlier on, right? Because switch can perform flooding for multiple types of frames, like sometimes it can perform flooding for unicast frame, sometimes your switch can perform flooding for multicast frame, sometimes it will also perform flooding for broadcasted frame as well, is not it? And now in future, whenever I'll go for STP spanning tree protocol, then definitely I'm gonna to teach you that how many types of frames we have, and how is it gonna to possible for switches to identify that which type of frame it received actually, like whether it is unicasted or multicasted or broadcasted. So I'll be discussing all these basic things during STP only. Fine. So right now you just need to know that this time, because switch 3 was not required to transmit a copy of that frame which was for VLAN 10 only in the direction of switch 1 as well as switch 4, but still it was transmitting that, right? So it was consuming network bandwidth unnecessarily. So this was the problem actually. We can solve it by modifying trunk allowed list on switch 3 itself. Fine. But the problem is you will require to do it manually. You will require to do it manually. So with using VTP pruning, we can achieve it dynamically. By using VTP pruning concept, by using this feature of VTP, we can achieve it dynamically. We will not require to modify trunk allowed list statically. Fine. Okay. The meaning by prune. What is the meaning by prune actually? It's kind of block. A meaning by pruning is what? Blocking. Fine. So remember that VLAN 1 cannot be pruned. VLAN 1 cannot be pruned. This is the rule of all switches, right? So VLAN 1 cannot be pruned, always remember. Fine. The next thing, after enabling pruning, what happens? That if switch is having any VLAN member, then only for those VLANs it will ask to its neighbor switches to transmit data. Fine. For an example, this time switch 2, because switch 2 is not having any user in any VLAN. Are you getting my point? This time switch 2 is not having any user in any VLAN. So because this is already in blocking state, so it will remain in blocking state, right? So now switch 2 will ask to switch 1 that I need data only for VLAN 1, because VLAN 1 cannot be pruned, right? However, switch 2 is not having any VLAN member in VLAN 1 itself, but still it will ask to its neighbor switch to transmit data for VLAN 1, because VLAN 1 cannot be pruned. So this time switch 1 will put this 0/2 in forwarding state only for VLAN 1. In same manner, switch 1 will also ask to its neighbor switches, like switch 1 also do not have any member in any VLAN, right? So it will ask to its neighbor switches like switch 3 to transmit data only for VLAN 1, and also switch 1 will ask to switch 2 as well that to transmit data for only VLAN 1. In same manner, now as you can see, switch 6 is having user in VLAN 10. So this time switch 6 will ask to switch 3 to transmit data for VLAN 1 as well as 10. So now switch 3 can ask to its neighbor switches to transmit data for VLAN 1 and 10. So switch 3 will ask to switch 1 to transmit data for VLAN 1 and 10, and switch 3 will also ask to switch 4 to transmit data for VLAN 1 and 10. So that switch 4 will put this 0/2 in forwarding state for VLAN 1 as well as for VLAN 10 only. In same manner, switch 3 will also ask to switch 5 to transmit data for VLAN 1 as well as 10. Okay, because switch 1 has received this request from switch 3 to transmit data for VLAN 1 and 10, so that now switch 1 will also ask to its neighbor switch to transmit data for VLAN 1 as well as 10. If any switch receives any request from its neighbor switch, right? Like for an example, switch 3 asked switch 1 to transmit data for VLAN 1 and 10. In that case, switch 1 will definitely ask to its another neighbor switch to transmit data for both VLANs, for all VLANs actually, right? Hello? So it's not like that switch 1 will be asking only for that VLAN in which it is having only members. No, if your switch has received any request from its one of the neighbor for any VLAN, then it will also ask to its another neighbor switch to transmit data for those VLANs as well. It's not it. So this time switch 1 will also ask to switch 2 in same manner, because switch 5 is also having used one member in VLAN 10. So switch 5 will also ask to switch 3 to transmit data for VLAN 1 and 10, and then switch 3 will also ask to switch 6 to transmit data for VLAN 1 and 10. Switch 3 will also ask to switch 1, has already asked. Switch 3 will also ask to switch 4, has already asked, and then switch 1 will also ask to switch 2, and it has already asked. So finally this will be your output. Now let's say again this user have generated some multicasted or broadcasted frame, right? So switch 5 will receive this multicasted or broadcasted frame. Switch 5 will check this trunk port whether it is in forwarding state for VLAN 10 or not. So is it in forwarding state? Yes, it is. It is in forwarding state for VLAN 10, right? So it means that switch 5 will transmit one copy of this frame out from this interface, and now switch 3 will receive this frame on its 0/3. Fine. So after receiving this frame here, then switch 3 will also require to transmit a copy of this frame out from each trunk port, right? But this time it will check that which interfaces are in forwarding state for VLAN 10. So only 0 by 4 is in forwarding state for VLAN 10. Is 0 by 1 in forwarding state for VLAN 10? Is 0 by 2 in forwarding state for VLAN 10? No. So this time switch 3 will not transmit a copy of this frame out from 0 by 1 and 0 by 2, but definitely it will transmit a copy of that frame out from 0 by 4. So switch 6 will receive it on its 0 by 4. So switch 6 will receive, because it was a broadcasted frame, so definitely it is also gonna to transmit a copy of this frame out from this interface as well, on which its user is connected, right? And user is member of VLAN 10 itself, so definitely it is gonna to receive this frame, and definitely then it will reply back, is not it? So this time switch 3 have not transmitted a copy of that broadcasted frame towards switch 1 as well as switch 4. So in this way you can save your network bandwidth by enabling VTP pruning. Okay, next thing, in future if you add a user here behind switch 2 in VLAN 10 now, so it will ask to its neighbor switch now to transmit data for VLAN 10 as well. So now switch 2 will ask to switch 1 to transmit data for VLAN 1 as well as 10, is not it? VLAN 1 as well as 10. And in same manner switch 1 will also ask to its neighbor switch 3 to transmit data for VLAN 1 as well as 10. So this time 10 will also be there. So this time whenever this PC will generate any broadcasted frame from here, switch 5 will check whether 0 by 3 is in forwarding state for VLAN 10 or not. So it is already in forwarding state, right? So it will transmit it towards switch 3, then switch 3 will check that which interfaces are in forwarding state for VLAN 10. So this time switch 3 will transmit a copy of this frame in the direction of switch 6 as well as in the direction of switch 1, and then switch 1 will check which interface is in forwarding state for VLAN 10. So of course 0 by 2, right? So it will transmit a copy of that frame in this direction now. Fine. So in this way VTP pruning works dynamically. So you could achieve same task by modifying your your trunk allowed list statically, right? But same thing, the same task has been completed by VTP pruning dynamically. So if you want to achieve this task dynamically, then definitely you have to enable VTP pruning. But if you want to do it statically, then definitely you can modify VLAN allowed list. I mean trunk VLAN allowed list or allowed VLAN list, whatever it is, right? So you can modify that trunk allowed list as well. Are you okay with it now? So you are having two solutions now, either by modifying your trunk allowed list statically or by enabling VTP pruning. Now which method you will prefer most? Trunk allowed list, to modify trunk allowed list. Like for an example, generally we do not prefer to use DTP to form trunking dynamically in between switches, right? In same manner you will also not prefer to use VTP pruning to achieve this task in most of the cases. In most of the cases you will always find like network admins will be configuring trunk allowed list only, trunk VLAN allowed list, is not it? You know why? You know why? Why don't we prefer to configure VTP pruning in switched network? Because in most of the cases you will see that your VTP mode will be configured transparent, and in case if on your switches VTP mode is configured as transparent, then forget about VTP pruning. VTP pruning can't work for those switches which are working in VTP mode transparent. Are you getting my point?
Yes.
So definitely you will find some of the switches which will be working in VTP mode transparent. So in that case this VTP pruning is not gonna to do, is not gonna to have any effect on those switches, right? That is why we will not prefer to implement VTP pruning in live networks. We will always prefer to modify VLAN allowed list on all trunk interfaces, on all trunk ports. So I hope that now you have understood that where can we implement this VTP pruning. So remember that if you are using the combination of server and client only, then definitely you can enable VTP pruning in your network, in your switched network. But in case if you are having some switches in transparent mode as well, in that case you will always avoid to enable to implement this VTP pruning in your switched network, right? I hope that now you have understood each and everything related to VTP pruning, because I have drawn this diagram in that manner only. Sometimes even you can also find some problems. You can also uh, have some problems due to VTP pruning. And remember that all VLANs can pruned except VLAN 1, but you can also modify this prune eligibility list. Prune VLAN eligibility list, you can modify it. By default, all VLANs can be pruned except VLAN 1. But if you want that, VLAN 100 should also not be pruned. VLAN 100 should also not be pruned. So you can also modify that list, which is known as prune eligibility list. Of course, 1002, 3, 4, 5, you cannot use them at all. Fine. So is there any problem now in VTP pruning?
So pruning is actually filtering VLAN.
No, it's not filtering VLAN actually. It's not filtering. VLANs will still be there. That's what my concern actually, that VLAN 10 will be available on all switches. That is why whenever switches will perform flooding, then that frame will go around the switch network, right? However, we were not having any user behind, switch 1, switch 2 and switch 4 in VLAN 10. So was it really necessary to transmit a copy of that frame in the direction of switch 1 and switch 4?
Just block this VLAN.
Data, not VLAN.
VLAN.
Yeah, it will block the traffic for those VLANs in which it is not having users behind, like switch 1, switch 2 and switch 4. Fine. So let me tell you one more thing here. Hello. Let's say you are having this diagram. Now I hope that VTP pruning will get, you will get more clear with VTP pruning. So this is, let's say, switch 2 and this is, let's say, switch 3. Fine. So let's say this is 0 by 1 and this is 0 by 1, this is 0 by 2 and this is 0 by 2 itself. Fine. Okay, let's say you have enabled VTP pruning. You have enabled VTP pruning. So this time if there is a user, let's say this is 0 by 2. Oh sorry, yeah, it is already mentioned. So let's say it is in VLAN 10. So now this switch 1 will ask to switch 2 to transmit data for VLAN 1 and 10. So it will be in forwarding state for VLAN 1 and 10. Then switch 2 will also ask to its neighbor switch to transmit data for VLAN 1 and 10. Fine. And then because switch 3 do not have any member in VLAN 10, so switch 3 is not going to ask for the traffic for VLAN 10 for switch 2, to its neighbor switch 2. So of course switch 2 will put the 0 by 2 in forwarding state for VLAN 1 only. Switch 2 is also going to ask for us to switch 1 only for VLAN 1 because switch 2 also do not have any member in VLAN 10. So will it be really possible for switch 1 to transmit data of VLAN 10 in the direction of switch 2 now? Let's say this PC have generated some traffic. Will it be really possible for switch 1 to transmit a copy of that frame out from 0 by 1 now? No, because 0 by 1 is not in forwarding state for VLAN 10. Yeah, if you are having a user here in VLAN 10 now, then switch 3 will ask to its neighbor switch 1 to transmit data for VLAN 1 and 10. Then switch 2 will also ask to its neighbor switch 1 to transmit data for VLAN 1 and 10. Any problem? Now switch 1. Of course it will be using VTP messages only to inform its neighbor switch, right? That is why this feature is built-in feature of VTP. So I hope that now you have understood the meaning by VTP pruning. Is there any question related to VTP pruning now? Sure. Should I go for implementation of this practical now? Okay, so let's do one thing. I'll be having switch 1, then I'll connect switch 3 to switch 1, then I will connect switch 4, and then finally I'll go for switch 2. R1 behind switch 1 or 4 behind switch 2. Let's say it will be in VLAN 10 only, and this is gonna to be in between switch 1 and switch 3. It will be using 19. Between switch 3 and switch 4 it will be using, tell me, 21. Between switch 2 and switch 4, between switch 2 and switch 4, 19. Don't you remember your diagram?
So we remember the diagram but not the port.
Oh. This console of R1 loose, check it out.
Maybe our one is not good.
Now it is on. Okay, see, this is switch 1, switch 2, 3 and 4. As I said that switch 1 will be connected with switch 3, right? Show CDP neighbor. So switch 1 and switch 3 are interconnected with using 19 and 20. So except 19, I will shut down all of the interfaces, right? Interface range fast Ethernet 1/0/20 to 24. So it would be connecting with switch 3. Show CDP neighbors, you see. Then let's move on. Switch 3. Show CDP neighbor. It must be connected with switch 1. It is already connected, and switch 4. So except 19 and 21, I will shut down all others, right? So interface range fast Ethernet 1/0/19, and of course fast Ethernet. Okay, 0/19, right? 0/19, and fast Ethernet 0/21. Okay, interface range fast Ethernet 0/20 and fast Ethernet 0/22 to. Fine. So now this switch 3 will be connecting with switch 1 and 4. And then let's move on switch 4 finally. Show CDP neighbor. Check it out. It is connected with switch 2 with using two interfaces. So what can we do? We can move on 0 by 20 and we can shut it down. Fine. So now it will be connecting with switch 3 and switch 2 only. So we have drawn this diagram now. And now I'll configure VTP version 2 and also I will enable VTP pruning and I will perform all these practicals. Fine. So let me show you. Show interfaces trunk. First of all, trunking must be there, so it is there, right? Then on switch 3 also trunking must be there. Show interfaces trunk. Yeah, it is already there. Then on switch 4 also trunking must be there. And then after, let's configure VTP. Show VTP status. Check it out. VTP version 3 is running. So what we need to do here, VTP, first of all, I think it is having some VLANs here. No VLAN 1023, right? And also no VLAN 1 to 100. No VLAN, what is it saying? Show VTP status. It's not a primary server. So let's move on switch 2 first and show interfaces. Show VTP status. Check it out. Is it primary server? No. It means we have to define them as a primary server first of all, right? So to configure them as a VTP primary server, the command will be VTP primary. For what? VLAN. Password was now no VLAN 1 2. Show VLAN brief. Now show VTP status. For MST, its operating mode is what? Off. Or what can we do? We can say VTP mode transparent for. This is the default configuration of it, right? And then we can try to say VTP version is what? But still it is saying that disable the password. So you have to say no VTP password. And then after VTP version is what? Oh, you show VLAN brief. Let me show you. No VLAN 10. So VTP. Now what happened? VTP primary for, because this time I removed password. So whenever you will add or remove password, it will always lose its primary status. It's not it, as I taught you in previous classes. So say no VLAN 1023. So now show VLAN. There must not be any VLAN, and now you can say VTP version is what? Show VTP status. Check it out. Everything is fine now, right? Then we can move on switch to show VTP status. It is still running VTP version 3. So what can we say now? Very first thing is no VTP password, and the second thing is no VLAN 1012. But again we have to make it primary server, right? So you have to say VTP primary and for VLAN. So it will become primary server for feature VLAN, right? Once it will become primary for feature VLAN, then after we can remove VLANs from its VLAN database, right? So no VLAN. Show VLAN brief. Now is it having any VLAN here? No. So now we can say VTP mode MST, sorry, transparent MST, and then we can say VTP version is what? Show VTP status. Check it out. Now it is version 2. So on all switches now VTP version must be configured as 2 and their domain name must be configured as CCIE. So let's move on switch 3 as well. So VTP status, it's running VTP version 1, no version 2 and domain name is already configured as CCIE. And in same manner on switch 4 also you must have same information, same configuration, like domain name is CCIE and version 2 is what? Enabled, right? CR number is 5 here. Here it is, yeah, it is also 5 and here it must be 5 actually. Yeah, it is 5 and on switch 1 also it must be 5. Show VLAN brief. Is there any VLAN now? Yeah, we are having these VLANs because might be that these VLANs were present on switch 3 and switch 4. Because on switch 1 and switch 2 their CR number became as 0, right? But switch 3 and switch 4 they were having their CR number as 5 and also they were containing these all VLANs inside their own database, right? That is why switch 1 and switch 2 have got have configured their CR number as 5 and also they have got all these VLANs inside their own database. Have you understood it now?
Yes.
Okay. Then after what can we do? I actually wanted to show you the impact of VTP pruning. So let me tell you one thing here. First of all, no VLAN 1 to 10 or VLAN your changes are not taking place actually. Let me do one thing. Yeah, let's try it from switch 4. No VLAN. Show VLAN 3. Is there any VLAN now? No. And now let's move on switch 1 first of all. Show VTP status. Check it out. Show VLAN brief. Now all have been removed. Let me do one thing. VLAN 10. Show VLAN brief. It is there, no problem. But if I say no VLAN 10, that's taking it. Actually, I made some changes on switch 1, but it was not applying those changes, right? So sometimes it can happen due to like database misconfig or something like that, right? So in that case you can try to apply your changes from different switches as well, right? So after all, let's talk about the VTP pruning now. Show VTP status. As you can see, VTP pruning is by default disabled. So what will I do? See, CR number is what? 8. So what will I do now? I will say simple VTP pruning and this time you will see that pruning switched on. Show VTP status. Check it out. Its CR number is now what? 9. It means VTP pruning must be enabled on all other switches as well now. Automatically, fine. So if you move on switch 2, on switch 3 like show VTP status, now it has been enabled. On switch 4 also it must be enabled. So show VTP status. So pruning must be enabled. On switch 2 also pruning must be enabled now. And if I want to disable it, then I will require to configure this command only on switch 1. Let me show you. No VTP pruning. So now pruning has been switched off. Show VTP status. This time CR number must be configured as 10 and now pruning must be disabled on all other switches. Like we can directly move on switch 2 and on switch 2 now it must be disabled. It means on all other switches also VTP pruning has been disabled. Now let me do one thing. Let me create some VLANs on switch 1, VLAN 1 to 10. So now you can see that we are having 10 VLANs in the database of switch 1 now, right? And all these VLANs must be present on all other switches as well. Like you can move on switch 3. So we must get all those VLANs here in the database of switch 3, inside the database of switch 4 and inside the database of switch 2 as well. So now all VLANs are existing in the database of all switches. Fine. And then after you can move on switch 1, you can see show interfaces trunk. On trunk interfaces you will see that all VLANs will be allowed here. Let me show you, because it will take some time to put interface in forwarding state due to STP. It will take at least 30 seconds to put your switch port into forwarding state for any VLAN. Fine. See here now. This trunk port must be in forwarding state for all VLANs now. Check it out. Hello. Have you got it now? Even if you move on switch 3, on switch 3 also, its trunk ports will be in forwarding state for all VLANs now, because we are having VLAN 1 to 10. So now this port, these trunk ports are in forwarding state for all VLANs. However, we do not have any VLAN member. Do we have any VLAN member on any switch right now? Of course, we don't have any VLAN member on any switch. Like you can check it on switch 1. You can check it on switch 2. We are having VLAN members in VLAN 1 only. However, still they are not active, because it is also necessary to have active member. It's not like that you have provided some VLAN membership but still port is not up. In that case, it will not it will assume that because this port is down in this VLAN, it means there is no member available for this VLAN, right? So this time you can see that there are a lot of interfaces available inside VLAN 1, but still all those interfaces are down. You can confirm it. Let me show you. Like here, oh, what is this? I think there are some problems on router 1 as well. This is R4 actually. Let me have console. Let me try to access the console of router 2. Yeah, it is possible. So remember, your VLAN member must be active. It's not like that you have provided simply VLAN membership and port is down, and then also switch will ask to its neighbor switch to transmit data for that VLAN, right? It's not possible. So let me show you now. So right now you can see that on all switches, show interfaces trunk, you can see that it is in forwarding state for all VLANs. Let me enable now VTP pruning here. VTP pruning, and you will see that VTP pruning will switch on now on all switches automatically, dynamically. Fine. So you can confirm it from switch 2 itself. Show VTP status. As you can see here, pruning is now enabled, right? And then after, let me show you one more thing here. Like this is R4 and this is R2. Even you can also access R3 as well if you want, but it's not possible, right? It's not possible to get the console of R3. All routers. Is R4 down?
Yes, sir.
No, it's working. It's working. Let me show you now.
Down.
But I think R2 is down. Yeah, or not. Which one? Leave it. Leave it. R4 is working fine, right? So only R4 is working fine. And now you can see, because we do not have any VLAN member available on any one of these switches, right? So this time show interfaces trunk, only VLAN 1 should be allowed on trunk port, you see, because VLAN 1 cannot be pruned. Okay, now according to this diagram, let me put this R4 in VLAN, tell me, 5. let's say this user is in VLAN 5. So if this router R4 will be in VLAN 5, then definitely it is gonna to ask to its neighbor switch like switch 4. So switch 4 will put this interface in forwarding state for VLAN 1 and switch 4 will also ask to what is happening actually. Here VLAN 1 and
5.
okay, so VLAN 1 and 5, and here again it will be in forwarding state for VLAN 1 and 5, and here also it will be in forwarding state for VLAN 1 and 5. So let me show you now. Let's move on switch 2 first of all, and on its FA1 by 0 by 4, let's say switch port access VLAN is what? So this time show VLAN brief, it will be having this user in VLAN 5. So definitely it will ask to its neighbor switch, which is switch 4. Show CDP neighbor. Let me show you. 19 is used to connect switch 4. Let's move on switch 4 now. Show CDP neighbor. Switch 4 is connected with switch 2 with using 0 by 19. Now show interface is trunk on 0 by 19. 5 VLAN 5 must be appear. It must appear over there. But as you know that it will take some time to put this interface into the forwarding state for that VLAN. That is why it is taking that time, because it will take at least 30 seconds. I think on router it is still shut down. Say, as I said, that if your user is not active, then also it will not ask to its neighbor switch to transmit data. Fine. So now, because it will come up, as you can see on switch 2 now, in this interface how came up, right? And it will also take some time to put this interface into the forwarding state, right? As you can see, show spanning tree VLAN 5, because this interface was a member of VLAN 5, so still it is in learning state. So it will take some time to put this interface in forwarding state for this VLAN. So still it is in learning state, and now it is in forwarding state. So now it will ask to its neighbor switch 4 to transmit data for VLAN and then switch 4 will ask to its neighbor switch 3 21, because as you can see in diagram, switch 4 is connected with switch 3 with using 21. So on switch 3 this 21 will be in forwarding state for VLAN 1 as well as 5. Then switch 3 will also ask to its neighbor switch 1. So on switch 1 this 19 must be in forwarding state for VLAN 1 and 5. VTP messages. In VTP messages only it will subset. Fine. Have you understood it now? That what is the uses of VTP pruning? So this task can be done manually, but with using VTP pruning we are performing it dynamically. So if there are users behind, on your switch for any VLAN, then only it will ask to its neighbor switch to transmit data for those VLANs, right? If your switch do not have any VLAN member for any VLAN, then it will never ask to its neighbor switch to transmit data for that specific VLAN. Fine. As we have seen everything over here. If any one of you having any problem, any doubt related to VTP pruning, please let me know. show interfaces pruning. Right, as you can see, VLANs pruned for lack of request by neighbor. So you can see 5 is not there. So now you can see show interfaces trunk. 5 is there in forwarding step. Now let me show you one more thing here. Show interface fast Ethernet 1/0/19 and then switch port. As you can see that all VLANs are allowed for pruning except VLAN 1. Let's say that I don't want to let my switch 1 to prune VLAN 10 or VLAN 100. What do you want? VLAN 10? Let's say that we do not want to let the switch 1 to prune VLAN 10 on this trunk port, right? So what can we do? Interface fast Ethernet 1/0/19 and then we can say switch port trunk, switch port trunk pruning, remove which one? So from this list it will remove now this VLAN 10 automatically, right? So it will remove only and only 10 from this prune eligibility list, which was from VLAN 2 to 1001. So this time you will see that show interface fast Ethernet 1/0/19 and then switch port. Check it out. Is VLAN 10 eligible for pruning? No. It means now on this interface, show interfaces trunk. Let me show you. Now for VLAN 10 also it is in forwarding state because it cannot prune VLAN 10 now. So in this way you can modify your prune eligibility list. Got it? For sure? That what is the meaning by VTP, how does it really work, and what is VTP pruning?
So what's the command to
You have a lot of options like fast Ethernet 1/0/19. You can say switch port trunk, pruning, VLAN. You can add, you can remove, you can use except keyword as well.
So here can we add VLAN 1? It's impossible.
No, it's not possible. VLAN 1 cannot be pruned because this is the default VLAN, right? So by default you cannot prune default VLAN because by default all users will be member of VLAN 1 only. So I hope that now you have understood the uses of VTP pruning now, right? So in this way you can modify this prune eligibility list, something like that, and all. Then is there any issue now related to VTP pruning? For sure. Okay, and I think that there must not be an issue related to trunk allowed list as well. Like by default, do show interfaces trunk. As you can see that by default all VLANs are allowed on this trunk port, right? If you wanna modify this trunk allowed list, then go to this interface and then you can modify this list, right? Like you can say switch port trunk allow VLAN and then same keywords will be available here like we have seen during the prune eligibility list as well. So it is same, but the thing is here you are doing it manually and VTP pruning will do it dynamically. That's the only difference. Due to will not work, STP will not work, but here it will keep on to do work in pruning, right? In VTP pruning, STP will keep on to do work, but in case of if you configure VLAN allowed list, right? In that case, STP will also stop to do work. Is it really like that? I'm asking to you. Is it really like that? Like for an example, just try to think about it. For an example, on a trunk port, Vinith, on a trunk port, let's say you have configured VLAN allowed list, right? Will it not be possible for switches to transmit BPDU for those VLANs out from that trunk port now? Tell me. Let me show you now. Show interfaces trunk. Here it is in forwarding state for these three VLANs only, VLAN 1, 5 and 10. Now let me show you. Show spanning tree. It is running for VLAN 1, 2, VLAN 3, 4 for all VLANs, right? When we configure VTP pruning. However, still you can see show interfaces trunk. On trunk port only these three VLANs are allowed, VLAN 1, 5 and 10, but still it is running STP for all VLANs. Now let me show you one more thing. Show spanning tree VLAN 1. For VLAN 1, this bridge is the root. For VLAN 2, this bridge is the root. For VLAN 3, this bridge is the root. For VLAN 4, it means for all VLANs this bridge is the root. Now let's move on switch to show spanning tree VLAN 1. Is it root bridge? No. For VLAN 2, is it root bridge? No. For VLAN 3, is it root bridge? No. For VLAN 4, is it root bridge? No. And root port is what? 19. For VLAN 5, is it root bridge? No. No, right? Now let's do one thing. Let's move on. Switch 3 now. So spanning tree VLAN 1. Is it root? No. For VLAN 2, is it root? Which one is root?
Switch 1 is the
Let me show you. Let's do one thing. On switch 1, for identification, let me change its priority now, right? So I will say spanning tree for VLAN 1 to 10. Priority is what? 0. Let's say I have configured it as 0. So definitely it will be root bridge now for all VLANs, right? For all VLANs now. So now what can we do? We can move on switch 3 and again we can try to see it. Show spanning tree VLAN 1. Who is the root? Which is having priority 1. For VLAN 2, who is the root? 3, 4, 5. Are you okay with it? For all VLANs, switch 1 is working as a root bridge. Then let's do one thing. Let's move on switch 4. So spanning tree VLAN like 1. No problem. 3, 4. It means switch 1 is the root for all VLANs. Even for for VLAN 8 as well. Finally, we can move on switch 2 as well. Show spanning tree VLAN like 5. It's switch 1. For VLAN 3, it's switch 1. For VLAN 7, it is switch 1. Fine. Now I will disable this VTP pruning and I will modify trunk allowed list. So let's do one thing. Let's move on switch 1 and say no VTP pruning. Show VTP status. Check it out. VTP pruning is disabled on switch 4, or you can directly move on switch 2. Show VTP status. VTP pruning must be disabled now, right? Now I will move on switch 3's 0/21 here, and I will allow only and only VLAN 1. I will allow only VLAN 1 here. So on switch 3, on its do show CDP neighbor, because which interface is going towards switch port 21. So interface 0/21. Switch port trunk allow VLAN only 1. Show interfaces trunk. So only VLAN 1 will be allowed. Is not it? Only VLAN 1. So now let's move on switch 4, and on switch 4 let's say show spanning tree VLAN 1. Who is the root bridge for VLAN 1 now? For VLAN 2, who is the root bridge?
Not switch 1.
It means it's not switch 1, because if it is a switch 1, it means its priority must have 2. For VLAN 3, its priority must have been must have been 3. But this time it is something different. 3 2, it means someone else, like either switch 3 or switch 4 have become root bridge. let's move on switch 3, switch 4 or switch 2, right? Because switch 4 and switch 2 are there. So either switch 4, because switch 4 is not working as root bridge, it means switch 2 have been configured as a root bridge, but only for VLAN. I mean, like for VLAN 1, switch 1 will remain as root bridge for all switches, but for other VLANs, I mean except VLAN 1, in between switch 2 and switch 4 there will be root bridge election, and in between switch 1 and switch 3 there will be root bridge election, because the traffic of VLAN, tell me, VLAN 2, 3, 4, I mean except VLAN 1 is not allowed via this trunk port. It means the BPDUs of all those VLANs will also not pass through this trunk port. It means that now if you move on switch 2, you can see that show spanning tree VLAN like 1. Still you will see that switch 1 is the root bridge, but for VLAN 2 you will see that itself, the switch 2 itself is working as a root bridge. So this is another difference between VTP pruning and VLAN allowed list. Fine. In case of VTP pruning, it will not filter your BPDU messages, but in case of VLAN allowed list, it will always filter your BPDU messages. Are you okay with it now? All of you? Fine. So we have completed now this VTP pruning as well as VLAN allowed list. Then after, let's talk about Ether channel. Or is there anything else in VTP? I think we have covered now all topics related to VTP. Fine. So let's go for Ether channel. So very first thing that you must remember for Ether channel, that why do we require to have Ether channel? Yeah, it is. So let's say this is switch 1 and this is switch 2. And of course it is always recommended to have redundant links in between switches, right? So if you are having redundant links, then you know very well, you understand very well. Let's say this is 0 by 1 and this is 0 by 2. This is 0 by 1 and this is 0 by 2. You know very well that STP will put any one of the link into the blocking state. STP will block at least one link among all these two links, right? I mean to say that STP will always put all alternate ports into the blocking state. Are you getting my point? STP will always be responsible to put all alternate ports into the blocking state. So here let's say that STP has put this 0 by 2 into the blocking state, right? Let's say the bandwidth of this interface is what? 100 Mbps, right? And the users, you are having a lot of users behind switch 1 and of course a lot of users behind switch 2 as well. And these users, lane users behind switch 1 and the lane users behind switch 2 are transmitting data to each other. You observed that the performance of network is becoming slow, right? Because a huge amount of traffic is going from switch 1 to switch 2 and from switch 2 to switch 1, right? Let's say there are some other links as well in between switch 2 and switch 1 like 0 by 3 and 0 by 4 as well, right? But you know very well that STP, by default STP will put all of them into the blocking state. So now you observe that the performance of your network is like, yeah, it is getting reduced, right? Or you can say now you observe that there is too much delay in your network. Performance of your network is becoming slower day by day. And I mean, like whenever you are adding some more users, in your network, the performance of your network is becoming slow day by day, right? Now you observed that, okay, it is happening due to lack of bandwidth in between these two switches only. The very first solution is that you can have a link of 1 gig in between these two switches to solve the issue of bandwidth. But let's say that you are not having those interfaces available on these two switches which are having bandwidth of 1 gig. So in that case you will require to replace these switches with those switches which are having uplink ports of bandwidth of 1 gig. But it is not really possible. I mean, it is not really easy for you to replace your switches, right? Might be that your company is not having that much funds, so that you can replace your switches, right? Now what is the next solution of it? We can configure here ether channel. Like we know very well that we are having redundant links in between, we are having alternate links in between switch 1 and switch 2, but we are getting only and only redundancy. We are not able to get load balancing due to STP only, because STP will be responsible to put all alternate ports into the blocking state here, right? So as you have seen that 0 by 2, 0 by 3 and 0 by 4 have moved into the blocking state. Only and only 0 by 1 will remain in forwarding state. So you will keep on to get redundancy, but you will not be able to get load balancing due to STP. So if you want to get load balancing among all these available physical links in between these two switches, then you have to configure ether channel. Means that ether channel is a feature by which you can bundle multiple physical links together in a single logical link, right? So basically with using ether channel you can bundle them, you can bundle all of them actually, and there will be a logical link. And remember that after configuring ether channel, it will create a logical link which is known as port channel. The name of this logical link will always be port channel, and STP will always look at port channel only. After configuring ether channel, you will see that STP will not be able to recognize these interfaces like this is Ethernet 0 by 1 or 0 by 2. No, now it will recognize all these interfaces as a single logical link which is port channel. Means that STP will be looking at port channel only. So now after configuring ether channel, after bundling all these physical links together into a single logical link, STP will think that there is only one link available in between these two switches. Vineet. So ether channel will required in these conditions only. Whenever you are having lack of bandwidth or you want to perform some load balancing to improve the network performance, right? Only to improve your network performance you will be configuring this ether channel between switches, right? So because by default due to STP only you will never be able to get load balancing in between these two switches. So to get load balancing you can use ether channel. You can bundle all these physical links together with using ether channel, and then ether channel will be responsible to create one logical link which is known as port channel, and STP will be looking at port channel only. STP will never look at all these physical links now after configuring ether channel. Fine. Now my question is to all of you, yeah, that's fine that after configuring ether channel it will become, it will create a port channel, and now STP will put this port channel because STP will think that there is only one link available. There is only one link available in between these two switches which is port channel, So STP will put this port channel into the forwarding state, and because you have assigned all 4 physical links to this port channel now, right? So if this port channel has moved into the forwarding state, it means all these physical links, all these 4 physical links will also move into the forwarding state. And if all of them have moved into the forwarding state now, it means there must be bridging loop. There must be a bridging loop, because between these two switches only we are having more than one link in forwarding state. And if it is something like that, it means there must be a bridging loop. But have you ever observed bridging loop after configuring ether channel between two switches? Why so?
Still will be participating only one of the ports. First operating port.
Tell me what is the reason behind it? Port channel. So STP will think that this is only port channel which is available in between these two switches. So STP will put this port channel into the forwarding state now. And you know very well that these 4 links will be member of this port channel. Is not it? This physical port 0 by 1, 0 by 2, 0 by 3 and 0 by 4. All these 4 interfaces will be member of this port channel. Are you getting my point? So now then after, let's say for an example, there is a host and this host have generated some broadcast frames. Switch 1 will receive this broadcast frame here. According to the load balancing algorithm, it will select any one physical link to transmit this frame towards switch 2. So let's say that it have selected 0 by 1. So switch 1 will transmit a copy of that frame out from this 0 by 1 now, and switch 2 will receive it here on its 0 by 1. Because it was a broadcasted frame, so it must perform flooding. And if this switch 2 performs flooding, then as you know that what is the rule of flooding, that it will transmit a copy of that received frame out from its each active port, is not it? So if switch 2 transmits a copy of that frame out from 0 by 2, 0 by 3 and 0 by 4, it means that frame will come back to switch 1, and it is known as bridging loop. Have you ever seen bridging loop? No. It means there must be some mechanism to prevent it, right? So remember that whenever a switch will receive any frame on that interface, on that physical interface which is already member of any port channel, then during flooding it will never transmit a copy of a frame out from that physical interface which is also member of same port channel, which are member of same port channel. Like here, as you have, as we configured all these 4 links into a single port channel, right? So all 4 these links are member of this port channel 1, let's say, right? So whenever this switch 2 will receive a copy of that broadcasted frame here on its 0 by 1, so during flooding it will never transmit a copy of that frame out from 0 by 2, 0 by 3 as well as 0 by 4, because 0 by 2, 0 by 3, 0 by 4 are also member of the same port channel in which 0 by 1 is there, right? Because 0 by 1 is also member of port channel 1, and 0 by 2, 0 by 3, 0 by 4 are also member of port channel 1. So it will never transmit a copy of that frame out from all these interfaces. That is why there will never be any bridging loop. Hello, have we understood it now? That how does it really prevent your switch network from bridging loop after configuring this ether channel between 2 switches? Fine. So this is the way actually. Okay. Now what if you are having like multiple ether channel configured between 2 switches? Let's say you have also bundled these 2 ports as well. Now STP will be taking place. STP will be taking place. You know how? Because this time you are having 2 port channels available between these 2 switches, right? So STP will see that, okay, there are 2 different port channels, right? So STP will put any one of the port channel into the blocking state to prevent your network from bridging. And if we say that STP has put this port channel into blocking state, it means that you know very well that let's say this is 0 by 5 and this is 0 by 6. 0 by 5 and 0 by 6 are the member of port channel 2, right? And because STP has put this port channel 2 into the blocking state, it means automatically these 2 ports 0 by 5 and 0 by 6 will also move into the blocking state. So there will not be any bridging loop. So these are the things by which your ether channel prevents your bridged network, your switched network from bridging loops. So I hope that now you have understood all these things. And STP, of course, it will be running here. It will keep on running here. Yeah.
So for example, the switch 1 has just one port channel to switch 2, and switch 1 receives a frame, just one frame. So even if it has got 4 ports, 4 physical links to switch.
Exactly. Now the question is, the big question arises here. Let's say this is switch 1. Are you getting my point? This is switch 2. And here you know very well that we are using like 21 and 22. 21 and 22. Let's say that we have bundled them. We have configured ether channel. And now you have multiple methods, right? Multiple ways to configure ether channel. Like you can use mode on, which is known as static ether channel, right? And also you can use either LSCP or PHEP. And in CCIE, because you have already learnt this PHEP as well as LSCP. So I'm not gonna to teach anything here, like what are the differences between PHEP and LSCP. I will simply do some implementation. Yeah, there are something which are really necessary to understand in LSCP, so I will be discussing all those things with you, right? So this time, let's say that you have configured ether channel, and now it doesn't matter that what you use here, either mode on or LSCP or PHEP. Finally, we are saying that you have configured ether channel, means you have bundled all these two links together, right? And you configured port channel 1 here on switch 1 as well as port channel 1 on switch 2. This will be actually your channel group number. Your port channel number will be depending on channel group number. So let's say that on both ends you took your channel group number as 1. That is why port channel 1 will be configured on both ends. Fine. Okay, then after, let's say that you are having some users behind switch 1 and also you are having some users behind switch 2 as well. The big question is, like, how will it be possible for switch to elect that physical interface? Because finally traffic has to go through the physical ports only, right? Traffic can't move via port channel, because port channel is a logical port and your traffic can't move in air, right? It has to go through the physical port only, right? So switch 1 has to elect, whenever switch 1 will transmit frame in the direction of switch 2, it has to elect either 21 or 22. So how will it be possible for switches to define that which physical port should be used to transmit your frame? With using load balancing algorithms, right? So because switch 1 has to perform load balancing for all those frames which are going towards switch 2, right, via this port channel among all physical ports. So it will be depending actually on load balancing algorithms. You must remember that for ether channel we are having some load balancing algorithms. Like for an example, if you talk about the equal cost load balancing on routers, so what do you mean by equal cost load balancing on routers? What do you mean by equal cost load balancing on routers? Like it will perform equal cost load balancing one per packet, right? One packet will go via this neighbor, another packet will go via another neighbor, next packet will go via neighbor 1, then again next packet will go, in this way, right? The meaning by per packet is what? One packet will go via one neighbor, another packet will go via another neighbor, is not it? So in this way your routers can perform load balancing, but here on switches for ether channel we do not have such kind of load balancing algorithms like per packet or per frame. We do not have something like that. Are you getting my point? There is nothing like per frame or something like that. Here we are having 9 load balancing algorithms, and I hope that all of you are remember all those load balancing algorithms, such as, like, first of all, source MAC only, right? And you must remember that by default your switches use this load balancing algorithm only, source MAC. Fine. Then you are also having destination MAC, and then you are also having the combination of source and destination MAC. Fine. Then you are also having source IP, destination IP, source and destination IP, then source port number, then destination port number, then finally source and destination port numbers, right? Second thing that you must remember, it is not really possible for all platforms to support all these 9 load balancing algorithms. You must remember it. Are you trying to grab it? That it is not possible for all platforms to support all these 9 load balancing algorithms. However, source MAC, this algorithm is the default load balancing algorithm for ether channel, but Cisco recommends to use the combination of source and destination IP address. Cisco recommends to use the combination of source and destination IP address as a load balancing algorithm, right? But remember that it is not really possible for all platforms to support this load balancing algorithm. Even on layer 2 switches you cannot change your load balancing algorithm. It is not possible to change your ether channel load balancing algorithm on layer 2 switches. But yeah, like if you are having 3 5 5 0 series of switch, in that case you can use either source MAC or first two. Even on 3550 you cannot use the combination of source and destination MAC address as well, right? Whereas 3750 will be supporting first 6, like source MAC, destination MAC, combination of source and destination MAC, source IP, destination IP. 3750 can support all 6 load balancing algorithms, whereas 4500 and 6500 series of switches can support all load balancing algorithms. Right now, my question is to all of you. We are saying that these all load balancing are available, but how these load balancing algorithms really works? Like, yeah, I'm agree with that point, that if you are using the source and destination both, then of course it will be using XOR gate. If you are using the combination of both source and destination, whether it is source and destination MAC address or source and destination IP or source and destination port number, it will always be using XOR gate to determine its exact physical port, right? But this time, let's say that you are using only and only source MAC address. So how will it be possible for a switch to define it?
Depending on the number of ports.
Number of the ports. Then how?
Basically, say if we got two ports in our channel, then we'll use only one bit, last one bit. If we got say 4, we'll use 2.
Yeah.
And the maximum is 8. So in that case, we will use the last.
Yeah, you also must remember all these things, that in a single ether channel, you can aggregate maximum 8 links. I mean to say that only maximum 8 links can participate in a single port channel actively at a time. However, with using LSCP, you can aggregate more than 8 links as well. But again, active number of maximum active links can be 8 in a single port channel, right? So you must remember it. Okay, what is the next thing in it inside ether channel? You must remember, I will come on this topic as well. I will also teach you these things, that how does it really perform this load balancing. Actually, it is not something, it is not something like that you said last one bit or something like that, right? I'll discuss it with you, but later on. First of all, let me tell you something related to ether channel as well. There are some pre-rescue site, right? There are some pre-rescue sites that we must follow before going to configure ether channel. Something like, as you know, tell me, what are the requirements before going to configure ether channel? Duplex, speed. Yeah, you know very well, speed must match, right? Duplex must match. Something, encapsulation. Okay, encapsulation must match. Something else? VLAN allowed list. Yeah, must be same, right? Like for an example, if on switch 1 you are gonna to aggregate 21 and 22, it should not be like on 21 you define something different VLAN allowed list, on 22 you are using something different VLAN allowed list, right? So on both interfaces, on 21 and 22, at the end of switch 1, before going to aggregate them, make sure that they are having same VLAN allowed list. Next, what is next?
Same interface type.
What?
Same interface type.
Same?
Interface type, like the bandwidth, like not bandwidth.
Agreed. Anything else? What? Yeah, of course, on a single switch you will be using either PVST plus or rapid PVST plus or MSTP, right? It's not possible to run two different spanning tree protocol at same time on a single switch. It's not possible.
Span.
What?
Span.
Span. Yeah, if you have configured span, do you understand the meaning by span? Switch port analyzer, right? In future, of course, I will be going through span as well. But remember that if you have configured span on any one of the interface to whom you are going to aggregate, right, then of course it is not going to do work. Is there something else? Prune eligibility list. Prune eligibility list should be same. Anything else? Like here, once if you have configured at the end of switch 1, let's say that you configured PAGP, right? because in PHEP you are having two different modes. One is auto, another one is what? Desirable. Then on another end also you must configure PHEP, because if you configure two different protocol on both ends, then definitely your port channel will not come up. Your ether channel will not be configured, right? So if you are going to configure PHEP, then make sure that on both ends you are using PHEP only. And if you are going to configure LSCP, then on both ends you must configure LSCP only, right? Hello, PHEP or LSCP. Use any one protocol, either PHEP or LSCP. I will also discuss the differences in between PHEP and LSCP as well. But before going for that, let's configure this ether channel between switch 1 and switch 2. And I will be configuring static ether channel in between switch 1 and switch 2, right? So let's configure it now. So to configure ether channel, let's move on switch 1 first of all. And because I have shut down all interfaces first of all, so I have to say no shutdown for 21 and 22. So interface range fast Ethernet 1/0/21, 22. So I have to turn on all these interfaces now. So I have to say no shutdown here. So once I will say no shutdown here on switch 1, then you will see that these links will come up. And now switch 1 will also be connected with switch 2. And I have to configure ether channel in between switch 1 and switch 2 now. Show CDP neighbor, as you can see that switch 1 is connected with switch 2 as well, with using 21 and 22. So let me configure now ether channel. And one more thing, here if I am saying show interfaces trunk, then it is showing me this 21 and 22 separately. Let me do one thing, interface range fast Ethernet 1/0/19, sorry, 21 to 22, switch port mode dynamic desirable. So now you will see that trunking will come up dynamically in between switch 1 and switch 2, because by default their switch port mode was dynamic auto. So interface is trunk. So under trunk interfaces you can see that 21 and 22 are coming here separately, is not it? Even if you see show spanning tree, like for VLAN 1, you will see that 21 and 22 will be displayed separately here. Now let's configure ether channel. Interface range fast Ethernet 1/0/21 to 22. Very first thing, that before going to configure ether channel, you must shut down your interfaces. I will let you know that why is it necessary to shut down your interfaces. Because sometimes what happens, that due to misconfiguration, your switch port can move into error disabled state as well. Your switch ports can move into error disabled state. So to prevent your network from these types of problems, you can do one thing. Before configuring ether channel, you can shut down your interfaces. But here I'm not gonna to shut down these interfaces. I know that it will work fine, right? So I have to say, like, sure, channel group, let's say I said 12, mode on. So it will configure now static ether channel here at the end of switch 1, fine. And now you can see show interfaces, so interfaces trunk. So previously it was showing 21 and 22 separately, but this time under trunk ports it will show you this port channel this port channel only. It will not show you those individual physical interfaces. Is there any problem now? No. Then after it, because I have configured here port channel, like port channel 12, and now it have also configured as a trunk port, right? Next thing, show ether channel. This is layer 2 ether channel. That is why this port channel have become as a trunk port. Trunk port, because if it is not a layer 2 ether channel, layer 2 port channel, it means it cannot be either access port or trunk port. Are you getting my point? So because this port channel is a layer 2 port, that is why it have become trunk port now by default, because by default its switch port mode was dynamic desirable. Okay, then after it, what can we do? We can move on switch 2 now, and in same way interface range fast Ethernet 1/0/21 to 22, and it is not necessary, it is not mandatory to use the same group number on both ends, right? You can have different as well, like channel group 21 mode on. So this time you will see that they will configure static ether channel between them, right? So you can see now on switch 1 show interfaces trunk, you can see that ether channel is there. Port channel 1 has been configured in between these two switches now, right? Then after, how can we come to know? that if this is MAC address and this is, I mean, if this is source MAC address, because by default in your Ether channel your default load balancing is going to be source MAC address. As you can see here, source MAC address is configured on both switches. Fine. So if we are having a frame, we know its MAC address. How can we come to know that which physical link will be selected by your switch? By looking at load balancing algorithm, right? But here you are not required to do any paperwork to calculate or to define that which interface will be selected by Ether channel, by port channel to transmit your frame. What can you do here? On switch 1 itself, you can move here and you can say test Ether channel load balance, and then interface is what? Port channel, and here I configured 12. As you can see that port channel 12 has been configured here, right? If you wanna see that, show IP interface brief, check it out. Port channel is what? 12. Show interface port channel, check it out. What? 12. How many interfaces are the member of this port channel now? 2, 21 and 22. And what is the bandwidth now? Is aggregatable, right? Because one leg was configured on one interface, right? So we have aggregated 2 different links. Each link is having bandwidth of 100 Mbps. So now the bandwidth of this port channel have become 200 Mbps. And one more thing, you cannot utilize this bandwidth 100%. Remember, in case of Ether channel, you will never be able to utilize this bandwidth 100%. 100%, you cannot say like that okay, I will be able to utilize the 100% bandwidth of this port channel. You cannot. I'll be discussing these things as well, that why is it not possible, right? But for now, say test Ether channel load balance interface was, we are using here source MAC, right? So I'll say MAC, and now it will ask me about source MAC address. So let's say that your source MAC address is 0201 dot 001A dot 120C. This is the source MAC address. Let's assume it, right? And now it will ask for destination MAC address. Let's say destination MAC address is 0202 dot 1122 dot 32D4. Any problem? Let's say that you wanna confirm that if this is my source MAC address and this is my destination MAC address, then what port will be selected by port channel to transmit this frame out from this port channel? What? Lowest MAC address? No, it's not like that. Actually, there is something different by which it elects its port, right? But here you can see that which port will be elected by. You can't say. You can't say that it would be 21 actually, because let's say, see, if you change your source MAC address, let's say in place of this 0 you took 1. What is that? So it's not always necessary that it will always be 21. It is not.
I think it's first packet for a round robin load balancing way. First packet forward from lowest port number, then highest. Then round robin the first packet. That's it. Round robin load balancing way. I think according to show.
I'll discuss it with you, don't worry. But for now, you see, if destination MAC address will get changed, port will remain same, because it is not including destination MAC address, right? It is not taking decision based on destination MAC address. It is taking decision based on source MAC address only. So this time you see that I will be change. I'll make some changes in destination MAC address, like 5, it is 22. Like 6, it is 22. Like 7, it is 22. It is 8, it is 22. Because destination MAC address is not taking place in load balancing algorithm. By default, it is using only and only source MAC address. So whenever you will change your source MAC address, of course your port will also get changed. Like for an example, this time I'll be changing, like in place of C, let's say it is 0, now it is 22, it is 1, it is 21, it is 2, it is 21 once again, and this is 3, again 22, this is 4, again 21, 5, 22, 6, 22, 7, 21, how? 8, 21. How you can say that it is round robin?
But usually it always select lowest port.
Why? No, it is not. It is not like that. Never. If it is doing something like that, it means, if it is doing something like that, it means that your traffic will never get load balance. It will go through via one link only.
It goes through one liter and if it goes then it selects another link.
No. I'm not saying that every time it will select a different port, but according to the load balancing algorithm, it will be selecting your interface. But every time, I'm not also saying that every time for each MAC address it will be using different port. Of course, like here you are having only 2 links available, right? So for some of the MAC addresses, it will elect 21 as the exit interface, and for some of the MAC addresses, it will elect 22 as the exit interface. But what if that one MAC address, one source is generating too much traffic, another source is generating low traffic? For a single source MAC address, it will always elect same port. Are you getting my point? Let's say that here you know very well that if your source MAC address is this 16, then your exit interface is going to be 22. And if your source MAC address is this 17, it means exit interface is going to be 21. Now this MAC address is generating, this source is generating too much traffic. So all that traffic will always go through 21. And this MAC address, this source is generating low traffic, too low traffic. It's not generating huge traffic, right? So its traffic will go via 22, right? So where will you find too much traffic? Where will be traffic congestion? On 21 only. That is why I said that it is not possible in Ether channel to utilize 100% available bandwidth of port channel. And if you are having 2 links available inside your Ether channel, because it is always recommended to have either 2 links or 4 links or 8 links. So if you are having only 2 links, it means that your traffic, your data will be shared in ratio of 1:1. In ratio of 1:1 means 50-50. That is why here, like you can see in most of the cases, for one MAC address, for one source MAC address, its exit interface is 21. For next MAC address, it is 22. For next, it is again coming 21. For next MAC address, again it is coming 22. But in some cases, you will also find that for multiple MAC addresses, there will be same exit interface elected by port channel, right? So what is going on in behind this source MAC address algorithm? I'll be discussing it with you in tomorrow's next class, right? But I hope that now today you learned this thing very new, that how to test, because for an example, and this command is really gonna to help you out during live network problems. You know what happens? For an example, you configure this Ether channel. After configuring this Ether channel, some of the users are experiencing problem that they are not able to communicate with users, let's say, or you can say that behind switch 2 there is an ISP, and there are some users behind switch 1. They are accessing internet, right? So some of the users are not experiencing any problem. But some of the users behind switch 1 are having this problem that they are not able to access internet. What can be possible cause? Because there is no problem related to route. Because if there is any problem related to route or netting, it means all users will suffer. All users must have suffered, is not it? But all users are not suffering. Some of the users, only some of the users, like 10 users or 15 users out from 50 or 25 users out from 50 are suffering with this problem. So what can be an issue? Might be after configuring ether channel, after bundling, this interface is having some issues, and all those traffic, all that traffic which is going through this physical link is getting dropped due to some problem actually. But still this link is participating in this ether channel actually, right? So it can also be a problem. So how will you come to know about this thing? If you are doing testing actually, that if this is source, this is destination, then which port will be selected by your switch, by your port channel, right? Then you will come to know that okay, these users are not able to access internet because they are having this source MAC address and their traffic is going through this link only, and the traffic of all these users are going through this 21. It means problem is existing on this link 21 only. That is why they are not able to access internet. Right? So this command will really help you out during troubleshooting.
Why it will select another port for another MAC address?
Because this link is still participating in your ether channel.
But both the links are participating in both the settings.
For one MAC address, for one source MAC address, there will be only one dedicated port. If it goes down, if its line protocol goes down, then definitely there will be only one remaining link. Then it will.
When both the links are up, and the switch and learn the MAC address from both the ports. So how it will select which MAC address it will use and place on the port?
Which MAC address?
Which port it will select?
So it will be using source MAC address only. The source MAC address of your frame is generated by your end user. There is PC will be responsible to generate frame. So whenever this frame will reach this switch 1, now switch 1 will check its source MAC address and accordingly it will select its exit interface. It can be either 21 or 22 based on load balancing algorithm. Let's say for this user, its MAC address is A, and for this MAC address, switch 1 is always electing this 21. It means the traffic of this user will always go via 21 only. It will never opt 22, right? So if there is any problem, any minor problem on this interface on this port, what will happen now? Its traffic will get dropped. But if there is another user which MAC address, its MAC address let's say is B and its traffic is going via 22, will it get ever any problem? Even if this link goes down 21, then because there will be only one link available for this ether channel, for this port channel, now this user will also not get any problem. So the problem was like this link was not down actually, but it was having any minor problem. So that traffic was not going through this link. At that moment, only your end users can have some problems. Understood it? So tomorrow I'll be discussing all these load balancing algorithms, LSCP, PAGP, everything. And tomorrow we are going to finish this ether channel and then after I will start STP.